Hi, so in the last few videos we've been practicing factoring quadratics, and now I'm going to talk about how to solve quadratic equations by factoring. So this technique right now only works for equations where a is 1. So the a term here is 1. So it only works for x squared plus bx plus c equals 0. So we know that if we set b equal to m plus n and c equal to m times n, then we can factor it as x plus n times x plus m. Now, after we factor this quadratic, it will become x plus n plus x plus m equals 0. Now, for this to equal 0, what has to be true? Well, for anything to be equal 0, you have to multiply it by 0. In this case, for this to be equal to 0, something has to be multiplied by 0. So if x plus n equals 0, then this whole thing will equal 0, because x plus n, which is 0, times x plus m will be 0. This thing could also equal 0. If this thing equals 0, that means that this whole thing will equal 0, because if you multiply anything by 0, you get 0. So after we factor the quadratic, we get two equations, x plus n equals 0 and x plus m equals 0, and then we can solve both of them for x, and then we have our solution. Now, this doesn't work for all quadratics because some quadratics aren't factorable. So right now, let's do an example, okay? So, let's do x squared plus 5x plus 6 is equal to 0. So the first step in solving this is we have to factor it. So what two numbers multiply to 6 and add to 5? Well, 3 and 2. So this would be factored as x plus 3 times x plus 2 equals 0. Now, we just learned that means that this equals 0 or this equals 0. So we have two equations, x plus 3 equals 0 or x plus 2 equals 0. So that means here x equals negative 3, here x equals negative 2. So the two solutions are x equals negative 3 or x equals negative 2. So quadratic equations have two solutions. Okay? So let's test these solutions to make sure they actually work. So let's test negative 3. So negative 3 squared is 9 plus 5 times negative 3 is negative 15 plus 6. This is negative 9. So 9 plus negative 9 does indeed equal 0. So that solution works. Negative 2 also works. Negative 2 squared is 4 plus 5 times negative 2, which is negative 10 plus 6, that equals 0. So that's how you solve quadratics by factoring. And let me do a few more examples. So let's do x squared plus 2x plus 1. Now this one's going to be actually pretty interesting. So how do we factor this? Two numbers that multiply to 1 and add to 2. That would be 1 and 1. So we have x plus 1 times x plus 1 equals 0. So actually right here we have that x plus 1 equals 0 and x plus 1 equals 0. But they're the same thing. So this is interesting. This quadratic has x is equal to negative 1 as the only solution. So some quadratics have only one solution, or the solution is repeated. And when we go over graphing quadratic functions, you'll actually know why this happens. So that was an interesting one. Let's do another one that's more normal, that is two solutions. So x squared plus 3x plus 2 is equal to 0. So let's do this. So we can factor this as x plus 1 times x plus 2. Yeah, those multiply to 2 and add to 3. That equals 0. We get x equals negative 1. We've solved this part. We have to solve this part too. So x plus 2 equals 0, or x equals negative 2. So these are our two solutions. If you plug them in, they'll work. I'm not going to prove it to you, but they will work. So that's that. Let's do another one. Let's do x squared minus 8x plus 15. We can factor this as x minus 3, x minus 5. If you don't know how to factor, you should probably watch my last videos. So we get x is equal to 3 or x is equal to 5. Since x minus 3 equals 0 or x minus 5 equals 0, because that will make that thing equal 0. Okay? So those are examples of solving quadratics by factoring. So yeah, I hope you like this video, and in the next video we're going to learn how to factor quadratics where the a term isn't 1. So real quadratics where the a term isn't 1. Well, when the a term is 1, it's still a real quadratic, but in the next video we're going to learn how to factor them when the a term isn't 1. So until then, I hope you like this video.